Hello everyone. In this lesson, let's study chain drive and gear drive technology. In our daily life, we often come into contact with various mechanical equipment, such as bicycles, automobiles, industrial equipment, etc. Most of the power transmission systems rely on chain transmission or gear transmission. These transmission modes achieve efficient power transmission in different ways and play a vital role in all kinds of machinery. Today, we will dive into the principles, applications, and key technologies for the design of chain drives and gear drives. By understanding their working methods, advantages, and limitations, we can not only better understand the power transmission of mechanical equipment, but also make more reasonable designs and choices in practical engineering. Next, we will learn through the following contents. Through the study of this class, I hope that everyone can master the basic principles of chain drive technology and understand the application of chain drive in mechanical equipment. You should be able to correctly select the type and specification of the chain drive according to the design requirements of the transmission system, reasonably configure the relevant components, and complete the design and debugging of the chain drive system. This aims to cultivate everyone's rigorous work attitude in engineering practice, enhance the ability to solve actual engineering problems, and at the same time stimulate everyone's thinking of innovation and optimization in the field of chain drive technology. First of all, let's understand the overview of chain drive technology. Chain drive is a transmission mode that transmits the motion and power of the driving sprocket with special tooth shape to the driven sprocket with special tooth shape through the chain. The chain drive is a meshing drive, and the average gear ratio is accurate. It is a mechanical drive that uses the meshing of chain and sprocket teeth to transmit power and motion. After understanding the overview of chain drive technology, let's learn the working principle and types of chain drive. As shown in the figure, the chain drive structure consists of a driving sprocket 1 mounted on parallel shafts, a driven sprocket 2, and an endless chain 3 wound around the sprocket. The chain is used as an intermediate flexible member, and the chain and the sprocket teeth are meshed to transmit power. In addition, there are mainly two kinds of chains used for power transmission: sleeve roller chain and toothed chain. The sleeve roller chain is shown in figure A below. The sleeve roller chain has a simple structure, low manufacturing cost, and is widely used. It is often used in the transmission of ordinary machinery. Figure B below shows a toothed chain. The toothed chain uses the meshing of chain pieces with specific tooth shapes and sprockets to achieve transmission. The toothed chain transmission is stable and the noise is very small, so it is also called silent chain transmission. The allowable working speed of toothed chain can reach 40 meters per second, but the manufacturing cost is high and the quality is high, so it is mostly used in occasions with high speed or high motion accuracy requirements. Then, the teacher will introduce the structure characteristics of sleeve roller chain and toothed chain. The sleeve roller chain consists of an inner link plate, an outer link plate, a pin shaft, a sleeve, and a roller. The figure below shows the sleeve roller chain. The outer chain plate 2 is fixed on the pin shaft 3, the inner chain plate 1 is fixed on the sleeve 4, and the roller and the sleeve and the pin shaft can rotate relatively, so the meshing between the chain and the sprocket is mainly rolling friction. The sleeve roller chain can be used in a single row or in multiple rows. The combined use of multiple rows can transmit larger power. The multi-row roller chain is shown in the figure below. Compared with toothed chain, sleeve roller chain is lighter in weight, longer in service life, and lower in cost, and is widely used in power transmission. The toothed chain is made by assembling a plurality of pairs of chain pieces with working surfaces at an angle of 60 degrees, with a pin shaft, and the working surfaces of the chain pieces mesh with the sprocket. To prevent the chain from falling off the sprocket during operation, the chain is equipped with an inner guide or an outer guide. When engaged, the guide piece is fitted with the corresponding guide groove on the sprocket. The toothed chain transmission is stable and the noise is very small, so it is also called silent chain transmission. It's widely used in high-speed transmission. The tooth shape of the sleeve roller chain and the toothed chain sprocket should ensure that the chain can save energy and freely enter or exit meshing, with little impact when meshing and good contact when meshing. After studying working principle and types of chain drive, let's take a look at the characteristics of chain drive. Compared with belt drive, it has no elastic sliding, can keep an accurate average transmission ratio, and has higher transmission efficiency. The chain does not require large tension, so the load on the shaft and bearings is small. It will not slip, has reliable transmission, strong overload capacity. It can work well under low speed and heavy load. Compared with gear transmission, it can have a larger center distance, can work in high temperature environment and dusty environment, and has lower cost. The disadvantage is that the instantaneous chain speed and instantaneous transmission ratio will both change, the transmission stability is poor, and there is impact and noise during operation. It is not suitable for high-speed occasions and frequent changes in the direction of rotation. Advantages over gear drive. Chain drive can have a large center distance, which is suitable for long-distance drive, while gear drive is limited by the center distance. Chain drive can still work normally in harsh environments such as high temperature and dust, while gear drive needs good lubrication and sealing. The manufacturing cost of chain drives is lower, and the production cost of sleeve roller chains and toothed chains is lower than that of gears. Gear transmission requires high manufacturing accuracy, difficult processing, and high cost. Chain drive is widely used in agriculture, mining, metallurgy, lifting, transportation, and other bad working conditions. Gear transmission is mainly used for transmission with high precision requirements, which requires higher working environment. The chain drive has the following disadvantages. The instantaneous chain speed and the instantaneous transmission ratio of chain drive are variable. The transmission stability is poor, and there are impacts and noises during operation. The instantaneous transmission ratio of gear transmission is stable, and the transmission stability is good, so it is suitable for high-speed transmission. Chain drive is not suitable for high-speed occasions. The allowable working speed of the toothed chain can reach 40 meters per second, but the manufacturing cost is high. Gear drive is suitable for high-speed transmission, with high transmission efficiency and smooth work. Let's discuss its application scenarios of chain drive. At present, chain drive is widely used in agriculture, mining, metallurgy, lifting, transportation, petroleum, chemical industry, forestry and sanitation machinery, and motorcycles with harsh working conditions and low requirements for transmission ratio accuracy. Let's have a general understanding of the 6 drive parameters of chain transmission. Let's take a look at several types of chain drives according to their uses. The first is the lifting chain. The lifting chain is mainly used to lift heavy objects in hoisting machinery. The working speed is V less than or equal to 0.25 meters per second, and it is suitable for low speed and heavy load occasions. The strength of the lifting chain is high, and it can withstand large pulling forces, but at a lower speed. Next, we will introduce the traction chain. The traction chain is mainly used to move heavy objects in chain conveyors. The working speed is V less than or equal to 4 meters per second, and it is suitable for medium speed and heavy load occasions. The structure of the traction chain is stable and can withstand large pulling forces, which is suitable for conveying heavy loads. Finally, there is the transmission chain. The transmission chain is used to transmit motion and power in general machinery. The working speed is V less than or equal to 15 meters per second and is suitable for low speed and high power transmission. The transmission chain has high transmission efficiency and is suitable for high power transmission, but the speed is low. According to the structure, it can be divided into the sleeve roller chain and the toothed chain. The sleeve roller chain has simple structure, low manufacturing cost, wide application, and is often used in transmission of ordinary machinery. The meshing between the chain and the sprocket of the sleeve roller chain is mainly rolling friction, and the transmission efficiency is high. The toothed chain drive is stable and has very little noise, so it is also called the silent chain, suitable for high speed or occasions required for high motion accuracy. The toothed chain has high manufacturing cost and high quality, but its transmission performance is superior. Here are 5 chain drive failure modes. Fatigue failure of chain plate. Impact fatigue failure of roller and sleeve. Gluing of pin shaft to sleeve. Chain hinges are worn. Overload pull brake. Next, we will learn about the center distance and chain length of chain drive. If the center distance of the chain drive is too small, the wrapping angle on the small sprocket will be small, and the number of meshing sprocket teeth will be small. If the center distance is too large, the chain will easily shake. The length of the chain is expressed by the number of links of the chain. The number of links can be calculated from the formula for calculating the length of the belt drive, but it must be rounded to an integer, preferably an even number. The center distance can be solved by using the formula. Finally, let's learn about the sprocket chain assembly of chain drive. The fit between the sprocket and the shaft must meet the design requirements, and the sprocket must not be loose. The fixing method of the sprocket should ensure that it does not loosen on the shaft, and ensure the reliability of the transmission. The parallelism error of the 2 axes of the sprocket should be within the allowable range, generally controlled at 0.2 mm for every 200 mm. Excessive axis parallelism error will lead to aggravated chain wear and affect transmission performance. The axial offset between sprockets must be within the specified range, generally controlled at 0.2 mm for every 200 mm. Excessive axial offset will lead to poor meshing between chain and sprocket, which will affect the transmission performance. After the sprocket is fixed on the shaft, the radial and in-face circular runout errors must meet the requirements, and are generally controlled at 0.05 mm. If the radial and in-face runout errors are too large, it will lead to increased wear of the chain and affect the transmission performance. When the chain is meshed with the sprocket, the working edge must be tightened and the meshing is smooth. Poor meshing between chain and sprocket will lead to unstable transmission and affect transmission performance. The sag of the non-working side of the chain should be appropriate. Generally, the sag is 20% of the center distance between the 2 wheels. Too large or too small chain sag will affect the transmission performance. Regarding the assembly method of chain drive mechanism, the following 3 points need to be paid attention to. Joint form of sleeve roller chain. Even numbers use cotter pins to fix movable pin shafts and spring cards, and odd numbers use transition links. The selection of joint form should be determined according to the number of joints of the chain and the use requirements. Fixing of sprocket on shaft. Fixing sprocket on shaft with keys and set screws. The fixing method of the sprocket should ensure that it does not loosen on the shaft, and ensure the reliability of the transmission. Joining of both ends of the chain. The center distance between the 2 shafts is adjustable, and the sprocket is at the end of the shaft, which can be connected in advance, and then installed on the sprocket. If the structure does not allow the chain joint to be pre-connected, the chain must be sleeved on the sprocket first, and then connected and assembled with special tensioning tools. The joint between the 2 ends of the chain should ensure that the tension of the chain is moderate and the transmission performance is ensured. After learning the relevant knowledge of chain transmission, we finally learn the relevant knowledge of gear drive technology. Let's first understand the way of gear drive. Gear drive is a mechanical transmission that uses the teeth of two gears to mesh with each other to transmit power and motion. It can transmit rotary motion and torque between two parallel, intersecting, or staggered shafts. According to the relative position of the gear axis, it is divided into parallel shaft cylindrical gear drive, intersecting shaft bevel gear drive, and staggered shaft helical gear drive. In addition, the transmission characteristics of gears are high transmission efficiency, closed transmission efficiency of 96% to 99%, compact structure, stable transmission ratio, reliable operation, and long service life. However, the manufacturing and installation accuracy of gear transmission is high, the price is expensive, and it will produce noise during operation, so it is not suitable for use in occasions where the transmission distance is too large. Let's introduce the application fields of gear drive. It is widely used in various mechanical transmissions, such as automobiles, machine tools, robots, etc., and is suitable for high-precision and high-efficiency transmissions. The gear drive has an accurate transmission ratio, and is suitable for occasions where precise control of motion and torque is required. At the end of the lesson, we will discuss the characteristics of gear drive. It has the advantages of high efficiency, compact structure, stable transmission ratio, reliable operation, and long service life. Its disadvantages are: gear drive has high requirements for manufacturing and installation accuracy, higher price, generates noise during operation, and is not suitable for occasions with a large transmission distance. In this lesson, we have learned the key basic knowledge of chain drive and gear drive technology. Through the demonstration of the courseware and in-depth thinking, you have not only mastered the relevant skills, but also deeply understood the importance of the sense of responsibility. I hope that in your future study and work, you can continue to carry forward this spirit and make greater contributions to China's engineering technology cause. Finally, please think about this course and complete the following exercise, aiming to consolidate the knowledge points learned today and further deepening your understanding. This lesson ends here. See you next time.